Everyone, and welcome to ITU Presents. We are honored today to be able to talk with an expert in IoT, the Internet of Things. Many of you have probably heard these words, but maybe you don't know exactly what it is. Well, we're very lucky that we have Sudeep Majumdar, who is an expert. He has 20 plus years of experience in this field, in the field of analytics and the Internet of Things. He is an engineer for a distinguished engineer for Oracle, and he has a deep understanding of cloud-based industry insights. He's going to come talking to you today about practical standpoint of where we are, where we're going, and some things to focus on. Not only is Sudeep a distinguished engineer, he is an author, a public speaker, and a great gentleman. So welcome aboard to ITU Presents. Thank you so much for being here today.
Thank you so much, Professor. Lovely introduction, actually. And students, I love to interact with you all because it makes me feel alive, it makes me feel agile, it makes me feel relevant, and makes me feel challenged, right? So whatever way I could, I would love to extend my hands to support in whatever way is possible. This is a very exciting time to be alive. Internet of Things. And as I said, this is a straight talk. And you must be hearing a tremendous amount of buzzwords going around everywhere, right? Wherever you look at. And just recent conversations, if you listen to or any industry stuff you look at, you'll always hear the words like a smart city. What the heck is that? You hear the word like an edge and IoT. You hear the word like IT-OT convergence, smart videos. What are all this stuff? What are all this, right? Okay. What exactly is the edge? People talk about edge a lot. What exactly is edge? Edge is nothing but, I'm just trying to make it very simple so that not much of jargon there because I understand it's interdisciplinary, right? Edge is something where the computing comes to the source, computing comes to the sensor, computing comes to the devices. So the edge could be a 8-bit microcontroller, edge could be a 32-bit microprocessor, essentially does certain things. And guess what? The cloud vendors, whether Amazon, Google, Oracle, Microsoft, anybody, they are trying to get into this. It doesn't mean this cloud is vanishing or disappearing. It simply means the cloud is coming to you much near. So that's what edge computing is all about. You always hear the term called gateway. So if you think the edge is a sensor, a smart sensor, and there will be thousands of sensors in a given factory, in your Tesla car, everywhere else, there has to be somebody to manage the coordinations, right? That's what the gateway does. So gateway is like a middleman, middleman between the edge and your cloud. So that's kind of an understanding about the edge. Second one, you see that, another buzzword you always hear, IT-OT convergence. So what the heck is that? OT is operational technology. Typically in the industry, whether it's a manufacturing or oil and gas or utilities or telecom, there's a huge amount of investment in the engineering operational aspect of it, be it the welding machines, be it the gigantic excavator machines, mining machines. Those are all operational machines and technology. IT, you understand that. Now there has to be some way to integrate this OT with the IT, meaning the physical sensor devices, all those things must get connected magically. Their events, their processes must get communicated magically to this hardware and software environment. So you bridge those gaps, OT, IT, or IT plus OT, that becomes IoT now. Another one also you hear, I'm not talking about all of them, just to give you an idea. Smart videos. Why? What exactly is this? You do all kinds of things, all kinds of things. So there's a way to process the data real-time fashion just about you. Now that particular thing about you, you merge with the context and mostly videos, then you have a real-time video just for you. Why is it important? Because people like you at that age group, you really do not love to read the newsletters of the world. You love to see a video. And if that video happens to be personalized for you from a given company, you would love that. So you see, these are the kind of buzzwords you see all the times right now, all over the place, right? So what exactly is the Internet of Things then? As I said, it connects, the device has the sensors, and it utilizes those sensors with the physical things, which is the hardware software combo. Okay, just to kind of drive you by an example, you got, I'm sure all of our have got parents who are older or grandparents, right? They're hearing aid devices. Hearing aid devices alerts you 2 hours before the things are going off the battery, right? A home thermostat can detect that your car is coming in 10 minutes time and makes the lights on and things like that, right? And the most interestingly, you will never find a similarity between Whirlpool, that guys who manufactures your dishwashers and ovens and stuff like that, and Yumly, which is essentially recipe website with Whirlpool manufacturing company. What exactly is the relationship? Oh, yeah, they're talking about smart cooking, meaning there's a camera insert there which understands the refrigerator, what exactly the things are there. And you try to cook, Thai, pad Thai or curry Thai thing, it exactly tells you, you know, interestingly, smartly, do this oven automatically wakes up and tells you, okay, the boiling water is done and this is done, that is done, right? So you try to combine that particular creative aspect of the cooking with the technology, make it an automated cooking. And it's not a fantasy, really. Believe it or not, this Whirlpool, they purchased Yumly, and now it's a part of their gig called smart cooking. So the thing is that this is the one aspect of the IoT. It might sound kind of a cheeky, but imagine itself another 10 years down the line, the way the water would be a scarce commodity, very scarce commodity. So in agricultural sector, everywhere you need to have an optimal use of water. An optimal usage of water can depend and cannot be done manually. Seriously speaking, you've got to understand the terrain, you've got to understand the weather, you've got to understand the crop you're going to produce, right? All those things has to be dynamically massaged and adjusted so that it can really adjust your smart pump to discharge the right amount of water. And the various of places like a very, how do I say this? It's not a very dangerous places like deep in the mining, the open cast mining, or the under the deep mining itself, or the deep in the oil and gas wells itself. There are tremendous amount of things there, the toxic elements. You got to have a sensors to get understanding of what's going on. You want to have all those things proactive and prescriptive. So this is what the technology can do to help the citizens, to help the companies to do much better things. And when you always hear that, and I'm just trying to be as simple as possible. People think that okay, if I have this kind of technology, I can it can help me proactively, predictably maintain certain things, do certain things before things go bust. And I'll give you a simple example. All of us fly, right? All of us fly. And if a flight from San Francisco to Singapore generates about 17 petabytes of real-time data, 17 petabytes. That's the amount of data it generates, right? And when a plane is late by 1 hour, it's called Airlines on Ground, AOG. It costs about $140,000. Okay, $140,000 per plane, 1 hour wait, 1 hour delay. That's the real money. So thing is that the real money can be saved because machine doesn't go bad just like that. One fine morning it decides, okay, I will go bad. No, it's not like that. It keeps on giving you the signals, but you are not able to capture that, right? So that's the key. You are not able to capture those signals so that you cannot react. So you react always uh, reactively, really. It's kind of sounds like an oxymoron, but you really react when the bad things, and part of my language, when shit happens, then only you react. Then only you react. It has got no value because when you have got the what happened kind of situation, what happened makes sense if and only if tomorrow is same as yesterday. Then what happens can make sense. But tomorrow is not same as yesterday, right? Then we have so-called predictive stuff. Why happened? Yeah, it's great. Why happened? It makes sense if tomorrow is same as today. Then you can take some actions. Why it happened? I need to address that so that tomorrow it should not happen. Things have moved. Things have moved to the prescriptive. What should happen now? right? So that's where the thing is all about. And what IoT does essentially improves the bottom line, improves the safety, improves the predictability, improves security, improves those kind of things, safety, security, predictability, right? Those are the kind of things IoT does. And that's what is the bottom line improvement. Now, so many people, as you can, I don't know, come on. And so many people think, okay, I'm investing so much of money on the IoT sides. Yes, it's great to see that I have much lesser downtime of my plants, machines, have a much more better productivity of my folks. If my dairy side itself, the salmon is going to go bad in another 6 hours down the 6 hours down the line, I should send a bip, 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 bip. I'm going bad. So it is a 50% discount on the salmon itself. All are great. But still, it is a much less fraud, much less leakage, much less those kind of things. It improves. How about making some money out of it as a service itself? Yeah, you can see so many companies are coming up. They provide those kind of tracking thing as a service. You want them, you just simply send them the data itself over the GPS itself. They can exactly track where things are at a given point. They can exactly tell you that how your drivers are doing, drivers overspeeding, underspeeding, whatever, right? Are they doing geofencing? In not so developed country, it becomes like, are they stealing stuff? Is there pilferage? All kinds of things you can remotely control sitting at a corner office. And in advanced country like us here, you can have a lots of proliferation of smart cities. Imagine yourself, you're sitting on the, like a network operating rooms, you exactly see what's going on in your smart parking, smart garbage, right? Smart fire detections, right? Whenever the garbages are full itself, that automatically sends you a signals. You accept the events, accept the signals. Then you ready the truck which goes and hauls this particular garbage itself. You have a work order and stuff like that, all done automatically. All of that, right? This is what the improvement is all about. This is what the money making is all about. So not only IoT, Internet of Things, it improves the bottom line, it also generates substantial amount of the top line growth. That's what I'm just trying to say. Now, this is interesting, very interesting. This is like a modern enterprise, modern digital business, right? You see the first one, customer obsessed. And you, all young fellows, right? How many apps you use? You know, gone are the days when the vendors like us or anybody like us tell you, okay, what to use. Forget about it. You really use things which are frictionless, which are only for you. So in your app itself, think about it. You maybe every day use 10 to 12 apps. How many you have installed so far? Maybe 50. How many are there in the iStore or App Store or Google Store? Millions, right? So exactly you know what you need to install or deinstall and use it. So nobody has to tell you anything, right? So that's called the obsessions, right? Second obsession is that, test and learn culture. Imagine those people like my age, it took almost like, at least my grandfather's age, or definitely father's age, it took almost like 2 to 3 decades to make radio, TV, those kind of things, phone, become popular in the mainstream. It took so much time to accept the technology, 3 decades. And guess what? Pokemon of the world, Twitter took maybe 3 months. Pokemon took 19 days to become accepted as a technology itself. So this is things have changed from that decades to this. So that's what the test and learn all about, right? And naturally, technology at the core. Technology is at the core, right? And this is where I think I would like to talk about a little bit on this. How do I connect my data securely and steadily and handle the way the data is generated, right? This is the key. Okay, we see tremendous amount of data being generated. And how do I handle it? How do I handle it smartly? How do I handle it securely? And I cannot stress more emphasis than this. Security is one of the most vulnerable area in the IoT and the technology itself. Bad guys can penetrate so many ways, and through your thermostat, they can hack your bank accounts. Plain and simple. Yeah, that's true. Now, to make things happen, you'll always hear the term called platform. Why platform is so important? Because in order to develop smart applications, you need to have a platform support. And that's the key. What does the IoT platform support mean? So you see the idea. You got the vast amount of data, and you know that you need to do something about it so that you can monetize that. You can improve your bottom line. You can have your top line growth. All those things, wonderful things you can do, but you just can't do it in a standalone fashion. So you cannot do it in one-off exercise. You got to have a platforms, and all the vendors like us, they all provide you platforms. So what does the platform do? And this is non-negotiable. This is absolutely not negotiable. First of all, it has to do a device management, and that's where the technology comes. Imagine yourself, you go to the Tesla shop floor, any telecom industry, any retail event, right? Tremendous amount of sensors and devices that they're all over the places. And the terminology you see, lightweight machine-to-machine intelligence, open mobile alliance, MQTT protocols, all those things are there. What does it mean? What does it mean? I'll get back to you quickly. Second one is the connectivity. It has to have a policy changes. Okay, for example, you are doing a prepaid cards or you are doing some kind of a services, we have a 30 gigabyte limit. It crosses 31. Will they stop it? Maybe not. If they stop it, they may lose you as a customer because you'll be pissed. But if they don't, if you exceed, they might lose money. So they have to make the judgment call. They have to see your profile, real time. Real time, they have to see your profile and think, okay, yeah, this person is a good person. So I think we can bill him or her later, right? Application management. Everything has to be done over the air. Nobody has a time, right? Nobody has a time to configure things. You want to change your SIM and do this, everything happens over there. If you're driving a Tesla car, everything happens over there. So over the air configurations, approvals, registrations, patch management, everything has to be done over there. Everything, right? And the last one, I love to talk to you about the zero touch provisioning. You know, zero touch provisioning is not funny because it means there is no zero touch. You get something, you get sensors, you put the sensors on, it powers up. And if it powers up, automatically it sends signals using DHCP to the wherever it is to get the latest image and download that particular thing on the sensor itself. You see this? So sensor, first time it comes, it gets shipped to you. You plug it in, be it your, smart, meters or whatever you have, right? Home offices, anything you plug in, first thing it does is to have a DHCP connections back to the wherever the latest image is there, download the software and starts working on it. That's called zero touch provisioning. So zero touch provisioning and the lightweight machine-to-machine intelligence. These are the really two key things to become successful. Because you think about it. If you're in the airlines or the airport itself, there are hundreds of sensors on the baggage sides, lots of sensors on the parking sides, on the catering side, on the trolley side, all over the places, right? How do you manage all of them? Do you physically go and touch them? No, no way. Do you physically go and upgrade them? No way. It has to be automatic provisioning. It has to be automatic provisionings, automatic calibrations, automatic configuration, all auto. You can think about it, right? Then all it will work. And firmware upgrade cannot stress you enough. If the automatic firmware upgrade is not there, it's just not there, right? So this is the key element. And within that, you'll always hear the two terms, MQTT and lightweight machine-to-machine intelligence. And MQTT and lightweight machine-to-machine intelligence, this is the two most prominent message broker to communicate, okay, to communicate. And within that, lightweight machine-to-machine intelligence is really key. It's lightweight, means it's a very thin footprint. And it is based on the improved secure socket layer. So these are the kind of things you try to have because you need to do the things very securely. It has to have an auto provisioning. It has to have an auto patching. It has to have an auto configurations. It has to have an auto upgrade. It has to support all over the air stuff because then only all your sensors sitting in this will make some sense. Otherwise, you will be in a big soup. I hope I'm trying to make the point clear. I'll get back to you on the questions on this side as well, because this is really important to understand this. And second, another thing also, I just go back again, I repeat that. You're talking about this is the streams of data going through this protocol, right? streams of data. And you have heard the terms MQTT, lightweight M2M, Kafka of the world. These are the streams. Unlike the normal streams, which has a destination, maybe the ocean or maybe another river, this stream is seemingly theoretically never ending, right? And what you need to do, you need to anchor that to get some sense out of that stream. So I'm just trying to get you the idea of the stream processing and anchoring, which is the MongoDB or any kind of a NoSQL database. That kind of a thing is nothing but the anchoring. But the streams are streams, okay? And this brokers help you getting that streams out of your edge to the gateway or out of the gateway to the cloud itself, depending on where things are at. And lightweight M2M has got very interesting thoughts. It has got two components, both client and the server. And both client and server, these two components are installed just on the edge device itself. This is interesting to know. As I said, edge could be a 8 bit microcontroller or 32-bit microprocessor. In the small, tiny little things with whatever storage they have, you have to have those kind of a client and server at the application layer itself, so that they can communicate and they can ensure that firmware upgrade and all those provisioning, patching, all of them can be done, because it's not a one-time situation. It is going to be there forever. Now, so we need to now see how we can make sure this kind of a rapid innovation happen, and what should be the org structure per se. Gone are the days of the development, and I run the development for a long time, where I've got batteries of people. Forget about this. It's now right now all microservices, all serverless architecture. Basically 2 pizzas and bunch of people, 2-3 people and done. It's a lots of services, not like a monolithic giant code. No, I came from that background, so I have a lots of fascinations or emotions about it. Even a mother monkey call her baby beautiful, right? So I have a lot of emotions about that. But the question is that when I see this API economy, API way of doing things, all small microservices, you are able to churn out the services every 2 weeks, every 3 weeks. Gone are the days of the vendors like us who used to have a release every 2 years, right? It helps you develop those kind of smart applications very quickly, because technology is changing very fast. Sensors are becoming smarter and smarter and smarter, right? Now, this is another technology which helps you really manage things well. This is called LP1. And the wide area network, WAN. What does LP stands for? Low power. Wow, what the heck is that? Low power. You're talking about sensors. They have to have a battery. It'll be in the cornfield. It has to be there for 10 years without supervision. You see my point? Like a low power. Wow, low power. How the heck do I get the signals of these low power things? And that's what the technology is all about. Low power operations. It has got a low bit rate, right? And very small bandwidth. And let me give you some metaphor. You want to send your water over a 1 mile distance, right? What exactly you need to have? Either you have to have a very high pressure of water, or you have to have a narrower pipe, right? Exactly the same way. If you want to communicate this bunch of sensors from the cornfield to some central server, wherever, right? You have to either have a what is it called, very high signal strength and very narrow bandwidth. Wow, high signal strength, narrow bandwidth, but have a low power. Aha. So you see, quickly you get into a situation where it beats the laws of physics, right? And there comes, so these are all this, LP1 players. And there comes our wonderful thing called 5G. Because 5G is seemingly address this aspect of it. Higher bandwidth, way higher bandwidth, and faster access. Wow, it's like a kind of beating the physics law. And if you see right now commercially, there are 2 kinds of implementation of 5G. True 5G, nobody has implemented. Everybody has 5G non-standard implementation. They call it a non-standard implementations. Other ones are standard implementations. When 5G standard implementation will happen, when there is a narrowband separate kind of spectrum will be there for the IoT, for the machines to communicate, because machine has to communicate, right? Machine has to communicate. And there will be always a latency when it communicates. Latency is something you cannot help. It takes time to copy image from one place to other place. They call glass to glass latency, right? And about 5 seconds is acceptable. 30 seconds is not acceptable. Okay. And that latency is very important, especially if you're in the healthcare industry, if you're in the mission critical industry, you have to have latency as small as possible. And that's where the 5G come into the picture. So 5G will really help in oil and gas, in the healthcare, in the operating theaters, and those kind of places. Yeah, retail and those stuff is okay, man. But this is a real opportunity for the 5G, and this is where the 5G has to get in there. But it's complex because 5G means your existing tower, existing server, existing mediation device, all those existing hardware, purpose-built hardware, which Cisco of the world or the HP of the world or Siemens of the world built, they would no longer be a hardware purpose-built. They have to be replaced by software. Okay, replaced by software, because cloud, the things can go up and down anytime. You just can't have a fixed hardware. So there's a lot of technology implications there, right? So that's why the 5G standard implementation is a little bit far off because of that reason, because they have to ensure that it should function the way current 4G LTE functions at a minimum. So I talked about the 1,000 feet level IoT. 1,000 feet levels, the left hand side, the sensors of the edge and the importance of the edge and the gateways and the message brokers, so you can get the stuff out. And why latency is important to understand the important. Why is the low power is important? Why this low power WN is important, right? Why is that lightweight machine to machine protocols are important? That's one aspect of it. In general, you can see that there is a tendency, and I don't want to say this publicly, but it's like this: cloud is getting matured. Cloud is getting kind of a given. Cloud business has to grow. Where can it grow? It has to grow only on the edge, because it is getting saturated in middle. It's centralized stuff. Okay, in data centers all over the place is there. Amazon has it, Oracle has it, Microsoft has it, everybody has it. So what's the difference? Instead of my office itself having their own hardware, I'm having it somewhere else. Great. But boss, the data are happening on the sensor side, on the electronic side. And that's a key. On the electronic sensor side, data are happening. So my processing has to go that side. And that's what is edge computing all about. Smart systems optimizations. This is key. So more the devices are there, device itself now becoming smarter. And I do advise some IoT database called HarperDB, one of them. And those are like a 70 megabytes, 100 megabytes, 100 megabytes, not even 1 gig, 100 megabytes footprint just on the microcontroller itself. On the microcontroller itself, you've got a NoSQL, SQL-like database there. So technically, that particular sensor, you can do a select. Wow, that's powerful. A particular sensor, you can do a select because it's there already. So all your processing can be done within the device itself. And that brings back to the notions called edge analytics. What exactly is edge analytics? That means it's event driven. Something happens to that sensor, something it is sensing, like a fish is going bad, it can tell you exactly that right away off the bat. So it's event driven. I can have some interesting notion about it, some kind of modeling. Okay, if I say that my fish is going bad, maybe my shrimp is also going bad too. Maybe not right away, but I can combine them together. Fair enough. So that's like a little bit of a mining models, which I did it before based on my sales data. I can put this back to the sensor itself. So this is called edge analytics. Everything happens at the edge, asynchronously, even there's no connection with the cloud, just standalone sensor. Beautiful. Then there's something called on the gateway side of it. There's a little bit more, there's a collection of sensors, right? I told you the gateway is nothing but a middleman between the edge and the cloud. So collection of sensors there, where I can do near real-time analytics. I can make much more senses. It's about a well in the oil and gas. It's about the maybe retail stores. It could be the airlines in a particular airport itself. For example, like in the airport itself, when the airport gets open, for example, right? There's an IATA 753 resolutions, which says that a customer should be able to see his or her bag across 5 legs. And it should do it automatically, proactively. Okay, to make that happen, that means your bag should be on a smart trolley. Smart trolley must be going to to security check itself, that it has to go into the belly. From the belly, it has to be uploaded to the conveyor belt, blah, blah, blah. So essentially, you should see every steps all the way through. And what's the plus point? By mistake, that trolley, you are supposed to go to Chicago, the trolley is going to Miami. You get notified right away. Agent can act right away. Agent can say, sorry, it has gone to Miami, but instead of you going to Chicago and finding out the bag is in Miami, and let's assume you're a wildlife photographer, then you are dead, or a performer, you are a dead meat. It can proactively send from the Miami to the Chicago. So before you arrive, maybe your bag has arrived. So see this beautiful example of how IoT can help. And that's what the gateway technology and machine level intelligence is all about. Then, of course, the right-hand side would be the cloud intelligence, cloud analytics, where it's all about historically what happens. You can build some smart models, do some predictive maintenance, predictive modeling, and push it back. You remember that, push it back to the sensor itself. So sensor has become very, very smart, low power, small form factors, and so forth. Right, and this boils into the sensor evolutions and proliferations. It is there everywhere, and I would like to separate two things out. IoT is on a consumer IoT, which you all are used to, I'm sure, and there's an industrial IoT. Industrial IoT is a big thing. It's really a big thing. Now, when I talk about the Industry 4.0, that's a term you should know, and you must get used to Industry 4.0. I'll tell you about it. So this is the proliferation of all the sensors you do not see with your naked eyes, but these are the sensors available all over the places and constantly capturing the data. I'm personally involved with Smart City in Palo Alto as well as Smart City in Phoenix. Wow, what a life-changing experience for me. Seriously, life-changing experience for me. I was involved with the smart railway network optimizations for Indian Railways. And in railway itself, the goods train, they make more money. They want to make sure that from a point A to point B, instead of 20 goods train, can they run 22 goods train? In the same track itself, instead of 26 tons per wagon, can they do 28 tons? This is the real money you're talking about. The more they haul, the more they make. And the sensors does help. How many sensors there? Sensor parameter? 480 parameters on the track itself. 480 parameters sensors are there to give you the real-time sensor so that you can really optimize the stuff. It's a very, very smart academic initiative, really. So how do I extend capabilities to the edge? So we talked about, okay, this is great. Cloud vendors are moving this. How I move my cloud technology back to the edge? Because edge doesn't have any processing capabilities, right? So the thing is that you develop on the cloud, infer on the edge. Yes, this is the term you use. Always you hear that. Develop on the cloud with all the tools and technology you have, centralized way. But runtime as a container, you put it on the edge and you certify that, right? So you operate at the edge, but you get the complete development environment in the cloud. So in terms of challenges on the sensors of the edge, we talk about deploying the edge agents, identifying the class of agents, updates, device compatibility, and edge storage availability. Out of this, device compatibility and the low power has been addressed by lightweight machine-to-machine protocols. In that itself, if you have a lightweight M2M protocols there, you can have varieties of diverse devices across vendors in your IoT ecosystems in low power without much problem. That's a key. Others still we are having an issue still. And how can I build IoT applications faster? I'm just trying to get both the technology and business come. It's kind of tough, but I will definitely take questions from you guys also. If you see, first question, and this is the survey done by I think Forrester or over one of them. First question is the where they want to have the IoT enabled use cases, where they want to focus on. Guess what? Security and surveillance. Security and surveillance, right? In every enterprise, five things are very important: security, safety, quality, security, safety, quality, predictability, and cost. These five are almost like a truth table for an enterprise. Five things: security, safety, quality, cost, predictability. These are the five things. And security always stands supreme. Why? Because as I said, security is the weakest thing in IoT ecosystems. Weakest thing. That's why you see the platform players are not doing that great. That's why you see the John Deere's and the Schneider of the world are doing, or Bosch or Siemens, they're doing phenomenally well in the IoT. Why? Because they manufacture the device, they understand the device very well, they know what happens, what doesn't happen, what kind of a systems or data this particular transducers or sensors give. They know their stuff. Vendors like us or Amazon or Microsoft or anybody as such, we don't manufacture sensors, right? We don't manufacture. Since we don't manufacture sensors, and naturally there is a vendor locking there, because Bosch or Siemens are not that dumb that they would let everything open to you. They will tell you, okay, boss, give me the money. I'll only share whatever I need to, whatever you ask for, right? Naturally, right? Why? One aspect is the making money. Other aspect is the security, because they don't want to be vulnerable. They just don't want to be vulnerable. They want to be make sure their boss, whatever you want, I'll give that to you in a very concealed, constrained API environment. And that's what I'm not making it an open API to my sensor or my devices, because at the end, I'm legally responsible for, right? So that's why you see always the one of those things is that security. Second one is the tracking and tracing. On the COVID side, you understand the importance of tracing. Tracking, I cannot stress enough the tracking. Tracking is one of the simplest things one must do. You must want to track your assets real time. You must want to see how the driver's profile. You must be able to differentiate between the bad and good driver behavior proactively. How many times he does brake? How many times he does the geofencing? How many times he basically stops for no reasons, right? All those things you want to understand real time. Real time, it is not insight, it is not analytic, it is simply the monitoring the real time, what the heck is going on. It could be my stores. I should be able to see real time what is my fast moving item, what is my slow moving items. I should be able to see real time. Remember the flash cells, old style, the flash blue light cells, those kind of things. You should be able to see real time, right? Energy and automatic. Now, car is a different ballgame altogether. So IoT application building step, essentially you try to combine the OT and IoT, and it should be the way you develop IT system, the same way you should be able to develop the OT systems as well on the edge. So same tool must work. Now, again, one size doesn't fit all. This is what I was telling to the professor all about. In the industry, specificity is very important. If you're talking to the retailer, you need to understand the term called tender, okay? You need to understand the term called SPIF. You need to understand the term called layaway. If you're talking to the network guys, you need to understand the term, the three-letter acronyms, GGS and SGS and IPv6, IPv4, all kinds of stuff, right? Because if you do not understand the terms of technology and the data they generate at those edge, at those sensors, you'll not be able to figure it out. So this is key. And in terms of, as you can see this, manufacturing is one area where the IoT is absolutely the hot topic. And I'll come back a moment later here. Another one is the transportations, then energy, the retail. These are the four areas doing phenomenally well. Of course, there are public sector surveillance, and they have been doing it for ages, right? So they know that stuff cold. But in the classic enterprise businesses, this is the real happening because they want to improve their bottom line and increase their top line. You can remember this: bottom line and top line. And bottom line means cost, quality, security, safety, predictability. Five things: cost, quality, security, safety, and predictability. Just to give you the digitization of the car itself, right? Imagine the car thing having a bunch of sensors, because to me, I drive Tesla, it's an IoT machine. So that's it. I really bought it just to understand IoT, honest with you, and how the whole thing works. And imagine the ecosystem it supports. It supports the insurance company, it supports the dealer, it supports the driving school, all kinds of things it supports. Complete ecosystem it supports because it's a sensors. And if it's a sensors using M2M, using MQTT protocol, using lightweight M2M, I can transmit the data securely and safely. So many parking folks and this gas stations or whatever insurance, they all have ideas what the heck I do, right? Very, very powerful. Just one shared mobility, right? Last one is my weak point. I think our weak point as an IoT professional itself is the security itself. Frankly, IoT security is out of sight, out of mind. You just do your job, fine. You just do not realize that, okay, how you make the company suddenly vulnerable, which they were never before. Security dashboard, detect, alerts, all of them has to be monitored and managed very well. And the challenges is this device has limited functionality or limited storage space to do any kind of a software development on this tiny little edge device, because otherwise edge device becomes like a big thick thing, right? It's no longer a sensor, it is no longer a $10 a piece, right? And you're talking about thousands of them. Lack of standards is another biggest pain in the IoT side, the standards. And as a result, every vendor has their own way of doing things. Is we talk about the multi-cloud environments, right? How difficult it is to communicate across cloud vendors. And the problem is more acute because cloud vendors are essentially softwares, right? You can do some kind of a standard bodies and maybe you can do some APIs and communicate from X to Y to Z, Amazon, Google, or Microsoft of the world, or Oracle of the world, right? On the sensor side is much harder. Why? Sensor is the just a value add for the existing huge $500,000 machines. Just a value add, right? But very important value add. And they don't want to divulge that. So it's very difficult, almost impossible if you're not a same vendor lock-in. If you're all in Siemens, you're perfectly fine. You're all in Bosch, perfectly fine. All in Panasonic, perfectly fine. If you're having a mismatch, good luck. You've got to really pay money, really pay tons of money to get the data out of those diverse sensors and make some sense out of it. So how do we do this? We try to making the security very intrinsic, least privilege. You provide the least amount of privilege to the people, micro segmentations at the, active threat detections, end-to-end trust model. In that, active threat detections is something only smart AI and ML can do that job. It's not humanly possible to do it. Detect a bot, to detect a unlawful entry of the spurious emails, you got to have an ML very, very smart. And the last one, and arguably, sensor side right now is a lot of buzz. Over time, you can see it will consolidate and it will become standards. So it will become standard. The price will come down. IoT implementation will come down. Edge software will come down. Gateway will come down. All of them will gradually come down. You see, the Tesla price used to be $110,000 before. Now you get the thrice the more functionality in 1/3 of the price, right? It's all will come down. It will become standardized, just like any hardware gets standardized, sensor gets standardized, everything will get standardized. The money down the line. So the thing is that if you're having an open tender, you'll always have a standardized component on the left-hand side, which is the hardware combo, the IoT edge sensors. Right-hand side, the analytics aspect of it, that will be the one which will make you money. You have seen, you have heard, data is the next fuel or something, right? Wow, this is great. I used to tell that sometime back, 3-4 years back. Issue is that fuel is a potential energy. It doesn't have any value unless and until you light up and make it a fire, then it becomes a kinetic energy, right? But energy gets transformed from potential to the kinetic. Great. And of course, it dissipates, right? It becomes transformed from one to other. Data is exactly like this. Tons of data you on the edge has no value unless and until you create analytics. Then it becomes potential data to real value analytics. But unlike fuel, you can create analytics on analytics, make it more perfect, make it more perfect. It becomes like your stock, right? It becomes like your stock because it adds value over time. So now data becomes another pillar. Usually you have the pillar like human resource, you have the pillar like a finance, you have the pillar like a locations, right? Now you have the next pillar, which is the data itself and analytics itself. So you see this value of analytics, so important. Now come the another important point, and I'm trying to drive this point because this is where the people are making money, or people will be making money. One needs to listen better. This is key. You have got omni-channel. Imagine, I'll just give you a simple example. Maybe you can appreciate that much better. May not be so relevant. Maybe it's here a little relevant. Suddenly you're going out of the building and you're losing signals, right? You get frustrated. That's all about it. But nobody gives a damn. Because if you call somebody, nobody gives a damn. AT&T will not give a damn. It happens all the time at Oracle office, right? Because in order to give a damn, they have to go back to the network events. They have to go and analyze the like a billions of network events to find out there's a drop calls happening, right? Who has the time to analyze? For what? Sudeep is upset. Give me a break. But guess what? Call center guys, they get some surveys, they get some calls. Oh, I'm not getting signals. Just a verbal, right? Or type text or whatever. Imagine yourself, you do some sort of a sentiment analysis from that call center voice or whatever you call it, right? What happens if you do a sentiment analysis? The verbiage, the word comes out. The call center becomes more prominent. Interference network, blah blah blah. It becomes much less. When call drop becomes more prominent from your text data, not from the network, from a text data, because people complain about the call drops a lot. Then suddenly you say, oh my God, the call drops are really happening. Then you try to correlate the call drops with the network events. Then you try to correlate. Before that, you don't care because you do not know where to start from, and it is a gigantic job. Now you know call drops is important, so so I need to correlate between this. I need to figure out where exactly is happening, why it's happening, what is projected things to happen. If the call volumes are going up because I'm giving, my iPhone 10 free, right? So people started buying it and then they're dropping it after 6 months or something like that. So do I care? Maybe not, right? And you try to do some kind of a smart mining there, smart technology there. Okay, what's the reason? Oh, signal strength, blah blah blah. Okay, fine, I can see that. Do I go back to my CFO? Say, oh sir, this guy, I have got such a fantastic promotion. The guys have been uh, subscribing to my behavior, so I need more towers, more money, so that I can support them. So screw you. Okay, figure it out. How many of them are real? After 6 months, will they stand? That's what happened to Reliance Jio, right now, third largest telecom company in the world. And they said, well, oh yeah, I get your point. Let me see how many of them are likely to leave. Then you have a churn models. People like me who never leave, fair enough. So there's a churn score. 5, the people have already left. So churn 4, maybe, are likely to leave. Then we try to find out, okay, what kind of people are there? Middle age. Okay, great. Are they business professional? In my loyalty cards, where do they fit? Titaniums, like highest value platinum, that kind of a thing. So platinum, middle-aged guys, business guys, spending over $200 a month. Yeah, good guys. How many of them? 1,000 people. Let me proactively send $50 to them vouchers. Sorry, sir, I understand you are experiencing blah blah blah. Here is the deal. You see, suddenly those guys become your ambassador. So suddenly, just because you listen to multi-channels, you listen to the survey guys, you listen to the survey guys, which you never did before, never did, first time, and you correlate that with your network, right? Then you correlate that with your CRM system, right? Wow, because the profiling, right? So see, suddenly your relational technology, your Hadoop technology, your real-time technology, all those comes alive. All of them come alive to solve a problem, right? And that's what the learn faster means, to solve the problems and execute smarter. Of course, you got to execute with the APIs to the CRM systems to call them up and provide those kind of a nice goodies. So this is key. Listen better, learn faster, execute smarter. And this is the various kind of ML and train happening. I'm talking about again, optimizing the cloud, infer at the edge. All those things you can do. You can create the models proactively on the cloud and deploy the model on the edge itself. Edge will be always event driven, but they can work with that particular model to do this. IoT 4.0 and fictions. This is the industrial world, right? We had the industrial version 1 when they discovered the pump and the water of the world, right? The industrial 2 when they have the electricity and the lots of machines and factory. Industry 3 means when the computers and automation came to the fore. Now is the industry 4.0, where this is the term In 2012 in Germany, they coined that. It's the fourth revolution of the industry. Fourth revolution, where computer will interact. All the devices are connected, interact with each other. So advanced monitoring, digital enhanced product, front and back end solutions, all of them supports it. That's what the industry 4.0 is all about. They interact. And the business was going to be huge. And how they translate from this to that? Because you want your factory to be smarter, your factory to be highly productive, your factory to be highly secured, safety, quality, and predictability. To make all of them happen, all the sensors and devices in the computers, they must talk to each other constantly, constantly talk to each other. And in that sense, with the robotic process automations, data exchange, cloud, cyber physical systems, big data, cognitive science, all of them can, so you can see this is a classic cross-disciplinary thing. Industry 4.0 is a concept, is an idea where all those things gradually merge in. The creative side of it, technology side of it, implementation side of it, it's a cultural shift. It's a cultural shift, really. You want to appeal to the large Kempi. He's one of the large giant in the welding industry. You know, their welding machines cost a huge amount of money, minimum $120,000 to $200,000, and the factories have tons of them. You just can't tell the welder like, oh, welder performance is this bad, that bad. They'll just say switch off. You got to communicate very non-intrusively to the CEOs. So IoT 4.0 has to happen from the CEO side. It has to be top down. It can never be bottom up because as a human nature, you do not like to be exposed. That's why you do not see blockchain taking that impact yet. It goes against the human nature if you try to make it bottom up. It has to be top down. So that's why I said everything has to have that ecosystems top down, cross disciplines. All the top heads has to agree to this. Now, for all of us, innovation is at the center of our digital transformation. People talk a lot about the transformations. We're talking about the low cost transfer, low cost sensors, blah, blah, blah. Life goes on. So this is the theory, right? This is what is theory. Everything is smart. Everything is an IP devices. Everything is great. There's a difference between the reality and theory, really. Look at this chart. 1% devices are connected. It's a little old, but it's pretty much maybe 2 to 3%. That's it. And interoperability, oh my goodness, that's pretty much non-existent. Everybody has grandfather's machines and motors. They want to make that work. Talking how do you make these analog devices to the digital and convert to the signals, man, it's a lot of work. So imagine, and things do produce stuff, right? It's not producing. The question is that why would CEO go and support, sir, Sudeep asked for this much of money for putting the IoT applications, IoT sensors, would you please sanction? Okay, I'm not losing money, man. Why should I do it? Right? Why should I do it? And sometime back, 1 year back, I guess, I was on the famous guy, the Carlos, the second or third richest guy in the world, right? I couldn't believe it. And we were meeting with him, and he was saying that he has got huge mines, silver mines, and he is losing a huge amount of money because all his $500,000 worth of machines suddenly goes out of the functions. The moment that kind of a machine goes out of the functions, the whole schedule went for a toss. There's a loss of productivity for 15 days to 30 days because there's no spare parts. You see? And these all mines are remote places. Imagine for Carlos kind of people, very deep pockets and celebrated industrialists, right? Very deep pocket. Those kind of people are feeling that kind of heat to run his mining operations, and it is running red for the first time in his life. That's what he said. Imagine the smart sensors can do for him. Again, the low power. Remember that we talk about LP1? Low powered one can do for him, lightweight MPM can do for him. Imagine the predictivity can do for him, because if you can have the sensors at all those various points within that huge gigantic machines of $500,000, right? You must be getting some signals right away to infer that this machine is going to go down. So essentially, pressure, sensors, vibrations, temperature, all of the viscosity, all of them come into play. Typically, there are 37, 38 parameters. So 37, 38 parameters, if you do it smartly, and if we can do some anomaly detections, right? Not a rocket science. You can proactively say, boss, this vibration is going on for quite some time. It is happening from this time to this time, and let's figure it out why it's happening. Wow, you have a solution there, right? So again, the field level, I talked about the vendor locking, field level integrations, huge issues. All the manufacturers, none of them talk to each other. Forget about that. Forget about the socialism here. Absolutely not, because this is their bread and butter, right? Why would they do? Why would they do? What is there for them? And guess what? People like us, what we do, we do not talk to each other. Now suddenly all cloud vendors are going back to them, going back to Industry 4.0, going back to OSD, which is the utility and oil and gas standard body, going back to the IOTA. Why? Sudden love for them. What we want to do? We want to understand what's their data structure look like. See, if there's a standard body, they must be publishing some data structure. Now I have an Amazon way of implementing, selling tons of IoT there. I have an Oracle way of selling tons of IoT. So is Google. I will just play by the standard body schema, because so far I am a vendor. I just do not have any idea what the heck is their data looks like. The moment I understand what's the data look like, I can plow back in right away with all my technology and sell the stuff. So you see why now all the cloud vendors are collaborating, right? And the good thing is that open source Linux Foundation, as I said, the standard body is missing here, pretty much non-defunct. Why not? I was a member of the Industrial IoT Consortiums, in when G Digital was at Prime. There are 250 members, right? None of the vendors talk to each other. 250 vendors, come on, give me a break. Have a standard. So now open source Linux Foundation, they did a very good job in the Linux, as you all know too well. They're trying to do something on the IIoT itself, industrial internet, industrial. That's very different from the consumer side. And you see that all the standalone business has to come to a common platform. So let's hope it works. Let's hope. Right. So use case by industry, top 5 is always asset tracking, utility monitoring, predictive maintenance. These are the very standard 5s across industry. You'll always see them. And especially for the manufacturing industry 4.0, you see the various aspects of it: forensic analysis, equipment, predictive maintenance. Again, predictiveness, let's say quality, cost, safety, security, predictability. These are the 5 things manufacturers, not only manufacturers, every enterprise care about. Manufacturing is more than compared to anybody else, because they have more sensors, they have more edges, they have more gateways, right? They have got more challenges. And data management challenge. I think we talked about it a bit. Operational technology versus information technologies. It's all kind of correlated together. And worst part is on the right-hand side, you have got is somebody else's Oracle CRP, SAP's manufacturing, somebody else's, Workday's HR, right? Siebel CRM or Salesforce CRM, all kinds of things. On the left-hand side, you have got all disparate data from the PLC and various other sensor boards and maybe different protocols altogether. So what we should do, is to leverage the data which you got it from the sensors and try to apply it, multiply. Remember, I talked about data becomes analytics, and I can do analytics on analytics, just like a stock. Same data can have various values and it can go to various places. So for the product itself, it can go here. For the factories, it can go here. For the machines, it can go that side. So that's the key. Get the data, try to proliferate as much as you can, because everybody has a different take, but the same data. So again, thriving on the same theme is that from the data itself, Machine Builder has a different way of understanding. You can produce the premium services. Cutting tools have a different quality-driven offering. Lubricants have a different level offering. Insurance have a different level offering, right? Same data sets. I was working with, what is it called? Williams, the paint company in Mexico, okay? They bought a company called Colored Fox or something. That company, without their knowledge, they lost 60% of their market, because they always sell by dealers. They have no idea. Whatever dealers tell them after 3 months, oh, this particular paint color is not selling well. This particular paint color is saying that much, or this kind of 2 gallons are not selling well, 20 gallons are selling good, whatever, right? They have no clue. What happens? After that, they put RFID sensors in every goddamn thing they do. Now, with a Sigfox, that low band or narrow band IoT, with a Sigfox, they can track every paint which gets consumed by the customer. Imagine suddenly they exactly know what color works, what color doesn't work, what size works, what size doesn't work. Wow. Imagine that how the manufacturing guys become real hero, right? Real hero. So that's what these people did. So this is the reference architecture. I don't want to bore you to death. You can see there's no vendor lock in here. It's all open source, Kafka based, Kafka stream, bunch of sensors, all the how the data flow do and how it syndicates and get enriched and the analytical apps there. So again, enrichment is the key. Enrichment is the key. Now this is my last bit. I do not know what time. This is my last bit where I'm giving my own spin, having been in this industry for a long time, right, becoming a dinosaur. What exactly I feel about it, 2, 3 years down the line. Really, I feel this. I feel now we have a digitization of the decision making itself. Nobody decides. It has to scale, digital scale. And what exactly digital scale means? Think about it. You have seen lots of places. You have seen lots of places where there is a small leakage. Some dirty programmer always make. I know that it happens in APAC a lot, Asia Pac a lot. Dirty programmers has 3 cents collected from the point of sale itself and put it to his own bank accounts. Of course, it has to be connivance with all the people, right? You do not realize this because it's a slow leak. You don't understand. 3 cents per transaction, who cares? 30 days later, suddenly you see a peak. And when you see a peak, you go and work. But you lose everything. You have a financial loss, you have a brand equity loss, you have a customer loyalty loss. Imagine if it's happened in stock trading, right? All kinds of places it can happen. All kinds of places. Second one, this is very standard. You are in the business of e-commerce or some play. You place ads, you deploy the ads on a specific browser. Suddenly it stopped working. Chrome particular version doesn't work. You don't know it. It is not shown correctly. Suddenly you see the number of clicks are much less. Number of clicks are much less, right? Boom. Same story. Same story. Third one. I'll maybe third of a couple of things. I'll stop there. Payment processing is deployed. This is what I've seen it so many places. It doesn't work on a particular iOS version 11 or version 12. Wow. Suddenly you have a series of, what is it called? The checkout cart abandonment. Lots of cart abandonment. Revenue dip, boom, you fix it, but it's too late. So thing is that so many things can cause breakdowns. So many things can cause slowdowns. And it's a question of opportunity or you go down the tube. It depends on you. If you are at the place where things are happening, and so data, this is one important thing. I know data because that's what I've been doing in my life. Data is a system of records that happens between one entity to another entity. It's a transaction, but it happens. What we need to do, we failed to do before, the context part of it. When it is happening, if I know how it is happening, why, when it is happening, how it is happening, then I can do a lot many things. I'm doing searching on the Amazon itself, some price. Suddenly I do a Google as well. I do all kinds of searches, see some of the lower prices. Boom, I dropped Amazon and get something else. Those are the context, you see? And why Blockbuster went bust or so many things, all the gig economy made all those companies, so many companies went bust, right? They should not have. Because what? Why? Because those enterprise had the data. Newbies, they don't have anything, customer data, they don't have anything. If and only if those enterprise knew that their most important asset they have the customer data, they could have leveraged, those newbies would not have come near. No way. No way. But they failed to react, right? And in the situations as you see, if you are in this business, anything can change. The partner can change, device can change, external systems can change, a company can change. And just ride sharing, you know, driver utilizations correlated with the peak in available drivers. This has to be real time, and you got to detect the anomaly itself. So anomaly detections on the real time is the key. Security alert is triggered with a login address, a fake email address. We got to really get these things done. As I keep saying that. And without AI or ML at the edge, it's not a cloud thing. It's at the edge thing. So simple way, the way we have been doing all along, and I'm sure you have seen that. You will see that in your companies as well, because all companies exist, all kinds of company exist, and this is what is my new realizations really. After talking to just before the COVID, I was with Alaska Airlines CEOs, and I was kind of shocked. Like when I started my career, those technologies were there way before I started my career, and they still exist. So they have old DB2 COBOL to the Java program, to the Web 2.0, to the IoT, to the big data, to the Hadoop, all cloud, all various places, all those diverse technology from 30 years back to present itself exist. And the answer was very simple. Sudeep, this is the business owners. They're happy with this. We have to support their business and we move on. Your job is to ensure that, okay, all of us can coexist. So I have a real new appreciation. I used to think, okay, man, these guys are not old. This guy is an old fart. This is not a cool technology. Why the heck? Yeah. But they have a business to run. So in a typical business, you see all of them. And if you're talking about this kind of businesses, this kind of a products, this many categories, right? You try to analyze so much of matrices, so many matrices, humanly impossible. You have all the pretty graph and things, but yeah, it looks good to the bosses, looks good to the CEOs. So what? And this so what business goes on. And this is my last one. So what we need to do, we need to have a platform which can do self-learn, self-service, real time, can do trend, can do anomaly, can do root cause, can do forecast, can do what if, can do optimizations. Detection service, prediction service, or prescription service, I should say. You see, this is what the platform should be for IoT, analytics, OT, cloud management, all of them. Finally, it has to converge into this. That's what I see. I think 2-3 years down the line, maybe the open source community, we can see something like that. Thank you. All right.
That was fantastic. So I'd like to first say thank you for that. We're going to open this up to questions here. If you would like to ask a question, certainly let's have you unmute and then feel free to ask your question. If you don't feel comfortable asking in person, you certainly can write it in the chat box as well. But I would definitely encourage you to ask some questions. It's not every day that you have somebody with this type of depth of knowledge in IoT and analytics. This is a pretty lucky experience here. I'd like to ask a quick question of you, Sudeep here.
Mhm.
You talk about where the industry was, where it is, where it's going, and the optimization of what's happening.
Mhm.
Who do you think are some of the leaders right now?
You put me a real fox. Okay, I get paid by Oracle, right? But yes, real dark horse, real horse right now. Honestly,
Mm-hmm.
I think one vendor has the game intact, which is Microsoft, in my opinion, honest opinion, compared to others, because Amazon has a very, very first mover advantage, no question about it. They kind of has a huge market share in terms of platforms, in terms of infrastructure. Google, late entrant, Microsoft has the right mix, because Microsoft used to be known as a consumer product, right? They moved into the industry space very fast. They're the right mix. I do not know. Another thing I personally feel, I've seen that, whether they would do it or not, I don't know. National, what is that called? Panasonic
Mhm.
and Siemens. This is the other two real Trojan horses. Siemens and Panasonic and Bosch. Those three. Yeah.
And you and I had the good fortune of being able to talk beforehand, and we were talking about data and looking at data and making sure that you're honest about the data
Hmm.
in terms of what's happening, in terms of where things are going, and smart cooking, even to the smart cooking
Hmm.
example,
Yep.
where things are going in terms of being able to, in real time, really be able to analyze things and move forward. What cautions would you have for people in terms of looking at data?
Lot. First of all, this is a hardware business, right? Hardware business means it has to be damn well, quality has to be damn good. Simple example, thermometer in the thermometer, which just measures the temperature, right? And maybe industrial set, maybe something at really high, whatever. The temperature, that thermometer can cost from $200 to $5,000. It does the same job. The quality of the hardware over time is very, very fundamental because it has to work in a very rugged environment. You just can't afford to have data suddenly give you initial 5 days, 7 days, 10 days, fine. Some rain happens, this happens, that happens, suddenly it starts giving you the garbage. You lose the trust in the system. No matter how much of enclosing you do, you lose the trust. The question is that the quality of the hardware is a hardware business in that sense, sensor business. The quality is very paramount, number one. You just can't afford to have noises. Even if it's have a noises, you have to have a smart AI just on the sensor itself to tell you, sir, Sudeep, I'm not able to give you the right noises. I'm not able to, the low color, the low quality camera you have in the Samsung smart fridge. I'm not really able to understand the ripe mango versus not so ripe mangoes. I'm not able to really understand that, right? So the thing is that those may be a little bit of fictional side of the story, but the fact remains is that IoT side, the hardware aspect of it, right now only the two countries really manufactures hardware, really, two or three. Taiwan, Japan, China, and Germany. That's it. Pretty much three, four countries. And of course, they've got factories in Mexico and everywhere else. But the thought leaders are essentially these four countries who manufacture the bunch of sensors in dozens. And that quality is very paramount. So if you have the quality sensors, then you can do wonderful things because so many things you have to do it by yourself. You get the chips and sensor 1, 2, 3, 4, 5. Then you have the integrated circuit board designs with all those chips and sensors and put the packages and making sure everything works. That's a lot of efforts and it has to be quality. It cannot be one-off thing. It cannot be one-off. So the thing is that investment on the quality sensors are key so that you can get much less garbage down the line. Initial 1 month, 2 months, 1 year, fantastic. But you're talking about long term.
Thank you. Let's have everybody turn on your screens. So let's everyone turn on your screens, please. Good to see everybody. That way our distinguished guest is able to see that real people are here. Thank you all for joining. Please go ahead and ask questions. I actually have so many questions, but this is a really wonderful opportunity for all of you. So please don't be shy about asking questions here. There's one question in the chat box, and I can read it to you. Here we go. And this is a great one because we actually were talking about you possibly teaching a nugget or two a little bit ago. So some courses, but here's the question. What courses should ITU teach our graduates to enter the IoT market? It seems to have a lot of areas to focus on.
Very good questions. I think IoT, edge computing and edge programming, edge manufacturing, I won't say manufacturing is a big word. Edge courses on edge computing and edge programming will be able to get you off the ground quickly to understand the IoT aspect of it. Of course, data science, analytic on the industry side, you can play with your strength or give an industry if you understand the industry perspective, industry's requirement. That's another aspect of it. But the first aspect is that to get some sense about the IoT, some sense, you got to have the IoT programming, Arduino of the world or Raspberry Pi, but edge programming, especially using ZPython of the world, right? Zython they call commonly, right? Edge with the C++ he has on the edge itself, developing both the client and the server protocols, understanding the communications aspect of it. So some understanding about the communications protocols, some understanding about the gateway, good understanding about the hardware. If these three things you have, then you cover significant portion of the left hand side, because after the broker it goes to the cloud. So cloud is a generic thing, but then AI part of it also, that machine learning is analytics also kind of generic, you can say, but if you are becoming industry specific, you can be much better. But the left hand side, up to the broker itself, it got to be good understanding. You got to really understand that. And it's a fun, believe it or not, it's a fun. When I graduated way before that, it is to a fun playing with the electronics, right? Fun playing with the truth tables, fun doing the soldering myself. It's a fun to put the diodes to remove the back currents flaw, right? It's a fun thing. And getting a good understanding of the electronics and hardware it will make you, because there will be lots of, remember, you want to differentiate yourself. And the way to differentiate yourself is on the hardware side. Trust me, in the Bay Area itself, you don't see many people doing the hardware well, know the hardware well, really. They're very good and smart on the rest of the thing, but the hardware part, only chips companies are fantastic, and that's it.
Yeah, I love your focus on the hardware. There's so much emphasis on software.
Yep.
And people often think of this cloud as this nebulous thing, this exciting thing, and they start thinking of this magical place called the cloud.
Yep.
But the reality is a cloud is an actual place.
Yes.
It's
a data center, is a saturated, and cloud is moving towards the edge. Yeah.
correct. And so when you talk about, everything in terms of the gateway and the hardware and obviously being aware of AI and machine learning that's going on, I think certainly we're touching on some of those for sure at ITU. But to answer the question, Sudeep and I were actually talking before this talk about some offerings that we can bring to ITU to help bolster some of the knowledge base, because this is something that is definitely not going away.
Yep.
And as Sudeep mentioned, this is a very fun, exciting field, and it's also a highly sought after and highly paid field.
Yes.
So it's not just that it's fun and exciting, it's actually a great career opportunity for those of you who are very interested in it.
And another thing, also, like, it's just not that, it's not the, some people are like CS background. Those guys do very good in terms of programming, right? No question about it, right? CS backgrounds and those backgrounds. But it's not just programming. It's a real thing. You can make some changes. You can see certain things, right? You can do all this wonderful stuff by yourself, remotely, looking at your home. Wow, I can power my computers, or power my microwave, or power my oven. Like, fun. It's fun, actually.
And if you're doing CS programming, it's very important to understand the IoT side.
Oh, yeah.
So I think that no matter where you are, to understand what somebody else is doing in whatever industry it is, it's critical.
And another thing also on the analytics side itself, I must tell you, I cannot stress enough, the good understanding of the statistics is a fundamental, absolutely fundamental. Without the understanding of the statistics, it's just, and it's like how do I say this? It's like a goalkeeper in football, football, not American football. Either you have it or you don't have it, the hunch. You got to have a hunch, what you're looking for. That hunch is very important, right? But solid background on the statistics will help you improve that hunch. So if, students, if I am you studying right now, I'll definitely go to, statistics 101 class or intro to stat class, always by myself, It may not be offered by ITU, but it's there in EDS from MIT, it's there in the Khan Academy, anywhere. So that understanding will really get you there. That's very important.
I have a question from the consumer standpoint, because you talk about being able to have these things that are seamless, having these things that are frictionless. So from a consumer standpoint, those of you who maybe won't go into this field, but an understanding of what from a consumer perspective is coming is
Yes.
you have something that's magically able to work,
Yes.
right?
Yes.
I mean,
And
so from a consumer standpoint, maybe talk with us a little bit about that and the ease of quality of life.
Yeah, think about, remember the old style when you used to have the modem or the router at home for connect to the network. You got to call Comcast, call AT&T, do all kinds of configuration. Now you just power in, boom, it's upping. Why it's happening? Because these are all smart provisioning. That is the last time you, as a human, touch there. That's it. Then it just sends the signals and gets the image, downloads, everything happens just like that. Yeah, exactly. Seamless, frictionless.
Yeah, as a consumer, it's so exciting, and it really does feel like magic.
Yeah,
that your refrigerator can tell you that you need milk.
exactly. Yeah.
All right. So what I'm going to do right now is I'm going to take a photo. So everyone, turn on your cameras, and I'm actually going to take a photo of everyone. And so here we go. For a couple of reasons. One, I want to make sure that we have a record of everyone being here. And two, again, it's really nice to see everyone's face.
Oh, that's great.
So here we go. 1, 2, 3. Okay. And then we'll take one more photo here. And here we go. And on this one, before we take the photo, if everyone can just say thank you to Sudeep, because this is certainly, I think most people don't always give up their Saturday nights to be with people. So I would love to give my tremendous honor and respect to you, and thanks for you coming here and graciously not only taking the time, but giving us such tremendous knowledge. So thank you very much.
Thank you,
you, sir.
Professor.
Thanks,
Love to
Sudeep.
share with the kids. That's
Thank
it.
you.
And whatever way you can
Thank
help,
you.
I can help. Yeah. And you have my email ID, so just send it to me.
Okay, here we go. And 1, 2, 3. All right. Now with this, I would love to, does anybody else have any questions to ask? This is the time. You have a genius in your midst. So this is a great opportunity for you. Any questions? Okay, if there are no questions, you and I will talk later because we have some courses to talk about.
Right.
And
We still have
thank
some
you for that in
questions from
advance.
you too.
But again, thank you so much, everybody. Sudeep is obviously going to go on for the rest of his weekend, and the rest of you stay here with me. We have a little bit to talk about here. So thank
Jake,
you.
I think someone has a question. I think. Is that right?
Yes, we have Arijit Das from YouTube that he told me he has one question.
Oh,
So-
we asked that one. That was the question. What should ITU ask?
Okay.
What should ITU teach? That was the question that was answered.
He said that he wanted to ask one more question, but he hasn't written right now. So yeah, I think we're fine. Thank you.
Yeah, if you have a question, certainly you can send it. If for some reason, I know some of you are having a little technical difficulty and I see some private messages. If it's okay with you, if we have some questions later on, would it be okay to send a question or two your way?
Absolutely.
Okay.
As I said, you share my email. I don't know whether you have the presentation. I shared the deck with Bill.
Yeah, we'll definitely share that. We'll definitely share that. Yeah. Again, thank you so much for joining us.
Thank you.
All right. And have a
Real
lovely
pleasure.
rest of your Saturday. Thank you for spending time with us. We very much
All right.
appreciate it.
Thank you so much.
Thank you, Sudeep.
Thank
Yeah.
you.
Thank you.
Bye-bye. All right. Now, everybody.